Okay, continuing on with our immune system conversation. Um, we talked about the innate responses. So the first two lines of defense that are protect your body against the vast majority of the bacteria and viruses that you count on. Your last line of defense is the specific immune response. And I shouldn't say it's the most effective, but it's the one that, hey, if something gets through the first two lines, the specific immune response is what cleans it up at the end and keeps our body functioning at the end of the day. Okay. Now it's the specific immune response for a couple of reasons. It is hyper specific to what it's attacking. Okay. The cells and the specific immune response are no longer just generalized tissues that are going to attack whatever comes their way. These are extremely specific cells that will be very tuned into attacking one particular species. Um, it's also known as the acquired immune response or adaptive immune response. That means you are not born with this. Okay, so a little bit about the phenomenon that we're all aware of. We all know little kids tend to get sick a lot. All right, that elementary classrooms are just full of sick kids. There might be kids randomly puking on the desk or doing different things like that. Um, why is that so normal for elementary classrooms, but as an adult that never happens? It's because as a young person, your immune response, in particular, this immune response, is still figuring out how to fight everything. Okay, it's gonna win. It needs some extra time, but it has to learn how to fight the flu. It has to learn how to fight the cold. It has to learn how to fight a variety of different things before you get to be an adult, and you're rarely going to get sick. I shouldn't say that. It depends on the person, but adults that have been exposed to a lot of things for the majority of their life that are healthy with a good diet and sleep and all that stuff, they're going to rarely get sick from things anymore because their immune response is so dialed into everything. All right. That's one thing as a teacher, I've always been thankful that my immune response is very strong or is very tough because I'm exposed to classrooms all day of kids sneezing and coughing and all of that stuff, and so my immune response has seen all kinds of things. All right. Once again, your body's response is very specialized at what it's attacking. You have cells that fight the flu. You have cells that fight the cold. You have cells that fight those kind of things. And not even that, you have cells that fight a particular strain of the flu and a particular type of the common cold. So they're all in there. This specificity is very effective, but it takes time. Right. So usually the pathogen gets into your system, it gets past the first two lines, then you start to feel ill, and then the specific immune response finally starts winning the battle and you start feeling better. Okay. There are two possible routes to go on this one, and it kind of depends on what kind of cell we're fighting. Here's the cell mediated response and the humoral response. We'll go through a little bit of them as we go. We've been carrying along this theme of foreign invaders or defending a castle, those kind of things. With the military and defense, your specific immune response is going to be a lot more like the Navy SEALs, right? So the Navy SEALs, today's military, they're not generalist anymore. They're not just building walls and fortifications and all that stuff. They are extremely focused on a particular target. Sometimes it's a single person that they are going after. It's also similar in that it takes time. Okay, it's not just let's show up on the beach and just storm the entire city. It is we need to spend a lot of time in reconnaissance and collecting data and gathering intel and making sure that this person is going to be in the place that we think they are, et cetera. There, just like your specific immune response, it's very specific. It takes time, and it protects your body. Okay, so how does it work here? All right. Your adaptive immune response requires B lymphocytes and T lymphocytes. Those are two big words. I'm going to refer to those as B cells and T cells from here on out. Maybe you've heard of B cells and T cells. They're part of the immune system, white blood cells, etc. There. Each B and T cell has many different receptor proteins on its surface that bind to a singular foreign molecule. So your cells are not like learning, okay? They don't have brains. They're not, you know, figuring this stuff out. It's your system as a whole that's creating a wide variety of B cells and T cells that are all unique, okay, with a bunch of different proteins on its surface that can bind to a bunch of different things. And what'll happen is these B cells, so you end up having millions of different B and T cells. These are floating throughout your bloodstream currently, all right? These millions of different B and T cells. If they bump into something that they're able to connect to and form and attack, they send a signal to the rest of your immune system that says, hey, this kind of cell is in our body. You need to mass produce things that beat it. Okay. So once the right B and T cell hits that that pathogen, then they're going to signal, hey, keep building a lot of cells like me so that we can fight this thing. That's why it takes some time, because there's no like a mastermind behind there. It's just these cells have to bump into it while it's already in your bloodstream, making you sick. And then once they do, it says, ooh, hey, time to start ramping up production of this particular thing. All right. Let me go back just a little bit. So with that, that's why things that we see all the time are a lot easier for us to fight, because there's chances are you're going to have more of these B and T cell type things. Very rare viruses are going to take a little bit more time because your body might not have ever made anything quite like that. All right. And it has different ways to see a virus, recognize it, tear it apart, and start producing cells that are like that. It just takes a long time. That's why COVID was such an issue for quite a few of us, because it was very different than what your body had normally seen. So a lot of people didn't have a great immune response. And so by the time their immune system was figuring out the puzzle, it might have been too late already. So here's a look at some of the cells here. All right. As we see our macrophage engulfing a bacteria, and it's saying, hey, these are the little parts that we need to be concerned about. Here it's going to be activating the helper T cells. Helper T cells are kind of the generals of the specific immune response. They're going to be like, hey, once they get and figure out what is attacking us, they're going to start mass producing these other cells. They're going to be making antibodies, they're going to be making memory cells, etc. there. So rather than drawing everything out for us today, I have kind of just some vocab. This will be helpful on the assignment here. So we have neutrophils. Neutrophils are suicide bomber cells that destroy infected cells. Destroy cells infected by a virus. So that's one of those roles. They'll come in and they'll blow up cells that they know are infected in order to prevent the spread. We have macrophages, right? We already talked about those, also called phagocytes, that engulf pathogens. If you watch the video on viruses, the white blood cells they showed in there were macrophages. Regular B cells, once they are activated and mature, they mature into plasma cells, and plasma cells in turn are going to produce antibodies. So you've heard that term, antibodies. Antibodies are little proteins that immobilize different pathogens that are in there. We flood them with these antibodies that surround the pathogen and make it useless. It can't attack anything, and then eventually your immune system cleans it up. You have killer T cells, right? Killer T cells are cytotoxic T cells, bump into infected cells. And they literally poke holes in them to destroy them. Useful for cancer cells. Like I said, helper T cells are kind of the generals. They're activating those killer T and B cells. And then the most interesting one in my mind, okay, the one that's probably the most useful, a great adaptation, is we have these memory B and T cells. So as you're sick, as you're a child, or even as an adult, and you encounter a pathogen for the first time, even while you're sick, your body's getting ready for the next time you see it. Okay. So as you're fighting that illness, your body's making these memory B and T cells so that the next time you see it, you'll have a backup supply ready to go and it won't make you sick a second time. I think that's a fascinating trait that we all have within us, is that the same virus very rarely can make you sick twice. Now, different strains, different mutations. If your immune system's weakened, that's a different story. But these memory cells help prevent against that. All right. Here's another look at that whole process and all these cells and what they're doing. All kinds of different pictures out there to check out. But our last slide that we're going to leave you with is what do these memory cells do? Now, this picture's a little grainy, but I like it a lot. First time you see a pathogen, you're here, okay? And it takes your body a while to figure out how to fight it. It's ramping up its immune response until it finally figures out the how to defeat it. You start to feel better, your symptoms go down, and your immune response comes back down to them. Well, the second time you encounter that same pathogen, your body's got those memory B and T cells in it. And so it says, oh, hey, we know how to fight this thing. Let's mass produce these cells so that it can't get to a critical mass where it's making us sick. All right. And then we see this huge secondary response in there. Okay. That is where I'm going to leave you at today. There is tomorrow or the next day, we are going to be talking about how can we get this secondary response without this primary response. All right. So is there a way that we can skip this primary response and just get the secondary response so we don't actually have to get sick the first time? We can actually just jump right into the secondary response. Spoiler alert, there is a way that we're able to do that. And we'll be talking about that next.